All right, let's dive right into this explainer. Today, we're unpacking a massive industrial puzzle. We are looking specifically at the electric utility sector to understand the life cycle of coal ash. We'll be exploring the best practices for safely managing these hazardous combustion products, and, believe it or not, how companies are tapping into beneficial revenue opportunities through recycling, all measured by the rigorous SASB sustainability accounting standards. To kick things off, I want you to think about this for a second. What actually happens to the millions of tons of waste left behind after a coal power plant generates our electricity? I mean, we flip a switch, the lights come on, but behind the scenes, there is a monumental logistical and environmental challenge happening. Seriously, where does all that leftover material go? Here is our roadmap for today. First, the coal ash dilemma. Second, severe environmental and financial risks. Third, waste to wealth. Recycling. Fourth, measuring the ash life cycle. And finally, policies for safe management. Okay, Section 1, the coal ash dilemma. So, when we talk about coal ash, what are we actually dealing with? Under the SASB standards, they officially define these as coal combustion products, or CCPs. It's basically a big umbrella term. It covers specific materials like fly ash, bottom ash, boiler slag, and flue gas desulfurization material. Basically, it's all the physical matter that's left over predominantly from burning coal. We're not just talking about a simple pile of dust here. It's a highly complex mix of industrial byproducts. Moving on to Section 2, severe environmental and financial risks. If this stuff goes unmanaged, the risks are literally catastrophic. We are talking about one of the largest industrial waste streams on the entire planet. It contains heavy metal contaminants that are directly linked to cancer and other very serious diseases. The absolute biggest environmental threat here, containment failure. If these heavy metals leach into the groundwater, it creates a massive health hazard for local communities. And from a business perspective for the utility companies, that translates into staggering litigation and remediation costs. It's a high-stakes issue on every front. Which brings us to Section 3, waste to wealth, recycling. Now, this is where the story completely pivots. It's a classic two-sided coin. On one side of the ledger, you've got toxic leaching and legal nightmares. But on the other side, utilities have actually found ways to capture highly lucrative revenue opportunities. Through beneficial reuse, this ash can be recycled and used to manufacture everyday building materials. Fly ash, for instance, can be used to make concrete stronger and more durable, and other CCPs are essential for manufacturing drywall or wallboard. So this massive, terrifying liability is literally being transformed into the walls of our homes, generating revenue for utilities in the process. Pretty amazing, right? Let's hit Section 4, measuring the ash life cycle. Since this transition from a dangerous liability to a profitable asset is so crucial, we have to know exactly how it's measured. The SASB standard explicitly categorizes coal ash management as a key sustainability metric for electric utilities. They use specific accounting codes, as you can see here, so that stakeholders and investors can transparently track how well a utility is managing this exact issue, which standardizes the data across the whole power generation industry. Specifically, metric IFU 150A.1 tackles this recycling effort head-on. It requires companies to disclose the total weight of CCPs they generate, sure, but more importantly, they have to report the exact percentage of their CCPs that actually get recycled by weight. It is a hard, quantifiable number that proves whether a company is treating their ash as a waste or as a resource. And this isn't just some rough guesstimate. It's a very careful calculation. The formula takes the weight of the ash reused or reclaimed internally, adds the weight processed for recycling by the company itself, and then adds the weight sold or sent externally to third parties for recycling. You take all of that, and you divide it by the total weight of CCPs generated. This strict calculation proves a genuine shift toward a circular economy. Finally, Section 5, policies for safe management. This framework is all about establishing the best practices for safely managing these hazardous products on the ground. The SASB metric IFU 150A.3 mandates a strict step-by-step product lifecycle approach. Utilities have to detail their policies starting right at the top with waste avoidance. Then they identified opportunities for recycling and repurposing. After that, they outline policies for the safe disposal of whatever absolutely cannot be recycled. It goes all the way down to remediation plans if an incident does occur, and finally, exactly how they safely decommission disposal facilities at the end of their lifespan. To make sure this isn't just lip service, utilities have to be totally transparent across a wide spectrum of areas. They have to prove they are safely managing not just their active operations, but inactive sites as well. They need to detail how they coordinate safely with third-party business partners and subcontractors.
And, interestingly enough, they have to navigate complex regional regulations, explicitly explaining if and how their own internal policies actually exceed the requirements of local laws.
Furthermore, they must explicitly outline how they assess potential environmental impacts associated with these combustion products. They've got to show their methods for ensuring strict compliance with their own internal safety policies. Basically, it is a holistic disclosure requirement designed to ensure absolutely no stone is left unturned when it comes to the safe handling and innovative reuse of coal ash. So, I'm going to leave you with this final provocative thought to chew on. We've just seen how rigorous standards, life cycle management, and innovative recycling can turn something as toxic and problematic as coal ash into the actual building blocks of our modern infrastructure. If we can do that here, what other massive industrial hazards are out there just waiting to become our next great resource? Thank you so much for joining me on this explainer, and keep looking for the opportunities hidden inside the challenges.